Artificial intelligence beats world champions at Go, predicts protein shapes more accurately than Nobel laureates, and generates essays indistinguishable from human writers. Yet that same intelligence can't reliably open a door, fold laundry, or pick up a dropped pen. How can AI be so smart in the digital world, yet so clumsy in the physical one? This paradox is the heart of embodied AI, the idea that true intelligence requires not just algorithms, but bodies that sense, move, and interact with the messy, unpredictable, real world. What is embodied AI? Embodied AI is the marriage of machine learning with physical robotics. Instead of models trained only on text, images, or code, embodied AI learns from physical experience, pushing, grabbing, walking, carrying. For decades, robotics advanced slowly, held back by limited hardware and brittle software. But over the last 3 years, something changed. AI breakthroughs like vision language action models, combined with better sensors and cheaper compute, have begun unlocking robots that can learn to operate in human environments. Professionals call this the last frontier of AI because cognition without embodiment is like theory without practice. Investors see it as the missing step between AI as software and AI as labor. Why it's harder than ChatGPT. Large language models scale because text data is abundant and training happens in simulation. Robotics doesn't work like that. Every door handle, every floor texture, every object has unique physical quirks. Data is sparse. There's no web-scale dataset of how to carry laundry baskets. Safety matters. A robot mistake can injure people, not just produce a wrong answer. This explains why companies like Agility, Robotics, Figure, Uptronic, and Sanctuary still run pilots rather than mass deployments. The problem isn't ambition, it's physics, economics, and data. The early winners? While humanoids capture headlines. The real commercial wins today come from narrow embodied AI. Warehousing. Locus Robotics surpassed 5 billion picks, proving autonomous mobile robots can scale profitably. OTTO Motors, acquired by Rockwell, is embedding embodied AI into factory logistics. Healthcare. Diligent Robotics Moxie completed over 2.2 million deliveries in hospitals. A quiet success story where AI already frees nurses' time. Inspection and security. Boston Dynamics Spot, priced around $75,000, is now standard on oil rigs, power plants, and defense sites. These examples show that embodied AI doesn't have to look like a human to create value. The humanoid dream, yet the long-term prize remains humanoid robots. The logic is clear. Our world is built for human bodies. Factories, warehouses, homes, everything assumes arms, legs, and eyes at human height. Agility Robotics Digit works with GXO Logistics under a multi-year agreement, stacking totes side by side with humans. Amazon piloted Digit in a Kentucky warehouse. GSO even reported paying about $30 per hour per robot under a robot-as-a-service model. Uptronic's Apollo is being tested at Mercedes-Benz factories in Europe, with a new pilot at Jobble. Figure 01 partnered with BMW to test humanoids in Spartanburg, while showcasing OpenAI-powered speech-to-action demos. Sanctuary AI's Phoenix demonstrated 110 retail tasks in a pilot with Canadian Tires, Marks, stores. These are not science fiction teasers. They are real contracts, pilots, and memoranda of understanding. But they are also fragile. Most deployments remain experimental. The economics of embodied AI. The investor question is simple. Does the math work? A U.S. warehouse associate costs $18 to $25 per hour, plus benefits. GXO's Digit Pilot suggests a humanoid might cost around $30 per hour today, still higher than a worker. But robots don't call in sick, don't unionize, and can operate 24/7. With scaling, costs fall. Hardware costs are compressing. Unitree's G1 humanoid sells for $16,000. Their H1 costs around $90,000. Consumer quadrupeds like Go2 or Xiaomi's CyberDog 2 are under $3,000. This is the pattern. Technologies debut at six-figure prices, then crash down as supply chains and standard platforms emerge. The AI stack. Brains for bodies. Hardware without software is lifeless. The real moat may be in embodied foundation models. Google SRT2, RTX, and OpenX embodiment. Vision language action models that let robots learn general skills transferable across platforms. OpenVLA, Octo, Bridge Data v2. Open source attempts to democratize robot learning. NVIDIA's project GROOT and GROOT-N1, designed to become the default brain for humanoid robots. Powered by Jetson Thor chips and Isaac Lab. PAL-ME, Gemini Robotics, RoboCat, embodied large language models bridging perception, reasoning, and motor skills. This is where investors should watch for platform plays, just as CUDA gave NVIDIA a moat in GPUs. Embodied AI may see a winner take most in training stacks. Standards and safety. Scaling embodied AI requires more than breakthroughs. It requires compliance. ISO 10218 defines industrial robot safety. ISO TS 15066 specifies collaborative robot limits. UL 3300 covers service robots in commercial settings. Without regulatory frameworks, adoption stalls. This is why many humanoids remain pilots. Compliance is still catching up. The hype versus reality paradox. Embodied AI is both overhyped and underhyped. Overhyped because general-purpose humanoids replacing millions of workers are not coming in the next year or two. Underhyped because service robots already deliver millions of packages, hospital services, and inspections. And investors often ignore this quieter revolution. The true story isn't in viral robot demos, but in the billions of real tasks already automated. We often judge AI by what it can say, write, or generate. But the real test of intelligence is not in words, it's in action. Embodied AI is messy, expensive, and still at the pilot stage. But every hour build, every tote moved, every pharmacy run completed pushes us closer to a tipping point. For professionals, the question is, which workflows can embodied AI augment profitably today? For investors, the question is, who controls the emerging platforms, the GROOTs, RTXs, and OpenVLAs of the robotics world? Because when robots finally scale beyond pilots, we won't just have AI that thinks, we'll have AI that acts. And that could change the structure of industries, labor markets, and economies faster than most people expect. If this video helped you, hit the like button and subscribe to my channel. Don't forget to watch my other videos.